Okay, so until last session, like we understood about how to write the PySpark command, how to use the PySpark APIs. So the possible APIs I've discussed, mostly used ones, 90% of the used ones I covered actually. Okay, so if I miss here and there like one or two, just let me know. I can discuss definitely in the class. Okay. So that is about the PySpark part. Now, today onwards, I'm going to start actually the Databricks part, which is very important to work in the real time, I can say. So before you get into the actual implementation, I mean, before you go ahead and create an account, you need to understand what is Databricks first of all, and its architecture also you need to understand. Okay. So let's get into that one. So we already have the Spark, right? Apache Spark, right? Which we installed in our local. So it is already there. Like, why we need to have the Databricks again here? Have you ever got that question? Okay, so let me answer that. So this Databricks is also actually started by the same people who found that Apache Spark, guys. Okay, Databricks is actually a company. So Databricks is a company founded by creators of the Apache Spark. So they started this Apache Spark project in UC Berkeley, somewhere in that location. I mean, that university and all. They started it actually, and they handed over that project to the Apache company. Okay, and they came out and they started the company called Databricks. Okay, Databricks is not a tool; it's a company actually, like Snowflake. Snowflake is also a company, right? Same way, Databricks is also a company. Okay, so like we already have Apache Spark. Like why they started another company called Databricks and what speciality they have now? That's what you need to understand. Okay, so Databricks offers a unified analytics platform optimized for cloud environments. Yes, when you compare with the I can say Apache Spark, Databricks Spark is actually much optimized, much faster, I can say, and it is compatible with all the clouds. Okay, I'll tell you the disadvantages or the drawbacks of the Apache Spark. Okay, so that we'll understand what additional things we are getting here. It addresses the challenges faced with the open source version of the Spark. You guys know Apache Spark is open source version. Even we downloaded that Apache Spark package from the Apache Spark website and we started configuring in our local, right? Okay, even the companies also started doing the same thing when the Apache Spark came into the market. Okay, see, we have configured with one system actually, with one cluster, I can say, or one node, I can say. But in industry or in the organization, they create a 10 node cluster, 20 node cluster, 32 node cluster, 64 node cluster, or 1000 node cluster, depending on the volume of the data that they have, depending on the volume that they're supposed to process. The more the volume, the more the number of nodes, I can say. So they used to install the Spark in those nodes and they have to integrate them and they have to create that cluster and they have to start like processing their data. See, that is again a manual task, right? See, creating a cluster is not a simple task. We have to install that Apache Spark in everywhere in that. If you're creating 1000 node cluster, of course, we have a automation mechanism to install in a single shot and integrate them in a cluster. But since though it is a like a one time task, but it is a manual task, of course. So and we get like that infrastructure issues. See, in the 1000 node cluster, definitely one or two systems will start failing at some point of time. I mean, that could be because of the hardware failure, could be because of the software failure, could be because of the network failure. Reason could be anything. So they have to manage that infrastructure as well. They have to have separate infrastructure management. And of course, if you get any software installations, I mean, the patches and all, or let's say Apache Spark has released a new version. Let's say last time last batch I installed actually 3.4. For your batch, I installed 3.6, 3.6, 3.5 or 3.6 something, latest version. And we have already like Spark 4.0 in the market. So Apache Spark is keep evolving. And every time the version got changed, we need to upgrade that version, right? Then again, that is a tedious task, right? People who are using the Apache Spark, yes, and they don't have user interface case. See, in order to run our Spark commands, what are we doing actually? Where are we running our commands? Jupyter Notebook.
Nodes, Jupyter
And
Notes.
Spark doesn't have any user interface, first of all. Spark is just a framework. It doesn't have any user interface. And they don't have any security management concept as well. Now your Databricks is actually bringing all these things. See, they came out actually after they handing over that project to the Apache Spark, and they started addressing all these issues. And they started this cloud, Databricks cloud. Okay, let me tell you all these things I just explained here, whatever I was trying to talk. Okay, so in 2009 and 2010, Apache Spark actually came into the market. The story of the Databricks began in the creation of the Apache Spark, an open source distributed computing system for big data processing. Spark was developed at the AMP Labs and UC Berkeley Labs, led by the researchers like Matai Jaharia. Now he's the CEO of the company, one of the co-founder of the Databricks, I can say. He's co-founder. Okay, he's still active in the LinkedIn. So he used to update actually whenever like some new updates and new features are there in the Databricks, right? He used to just post that one in the LinkedIn. One second, just a second. Yes. Oh. So he used to post that one in the LinkedIn. Okay, one of the co-founder. Okay, I mean they're actually creators of the Apache Spark. Okay, and the Databricks company they started in 2013. Uh, with a commercial product. Commercial product in the sense like Databricks is a product, that's it. So it is much better than Apache Spark. With that concept, they came into the market. Okay, with that too with cloud. Backend, they started the cloud concept. But the problem was actually by the time these guys are in market, okay. See, in February 2014, Databricks launched Databricks Cloud. So in 2013, they just came into the market as a product. In 2014, they started actually a cloud, Databricks Cloud. Okay. So the bad thing is actually by the time they came into the market, these people, the big gains actually like AWS, Azure, and GCP started grabbing the market. They started grabbing the market. Okay. And that too, what these people are doing, like AWS, Azure, and GCP, they started installing that Apache Spark in their own cloud, and they started like making products. All these ADF or your glue, your this one, what do I say, Redshift. All these like products are built on top of Spark only. So-called ETL tools in the big clouds actually built on top of Apache Spark only. So they started like making products with the help of that Apache open source Apache Spark. So obviously, if these guys are coming into the market, then obviously nobody cares these Databricks, right? Though they are coming with the strong points, but obviously people will fall people will start like following these guys on the right, AWS, Azure, and GCP on right. At that time, like Databricks started thinking, hey, instead of like creating a new cloud from our end, so let's tie up with these cloud guys like AWS, Azure, and GCP. Now, what these guys are saying is, Databricks people, they went to these big gains and they started saying that, hey, I have a product actually that is Databricks product. Okay, so it can process huge volume of data, and I do have cloud, but I don't want to use my cloud. I will use your cloud. When I say cloud, in the cloud, what do they use actually utilize? See, in order to run your commands in Databricks, we need to have some compute power. See, if you want to run something in the on-premise, if you want to run your Apache Spark commands, what do you need? Without my laptop or without my system, can you run the commands? Can you run the commands? See, I just have a software, that's it. But if I want to run something, what do I need? I need some compute power, right? Compute power is required or not?
Yes, bro.
Yeah. So that compute power is actually they are taking from these guys, AWS, Azure, and Google GCP. That compute power is nothing but the compute power is nothing but a system. It's a node. See, if you want to create a 4 node cluster, so just within fraction of seconds we can do that in the cloud. Okay, and we are going to give only UI, and we are going to utilize that compute power from your cloud. That's what they started like talking to the AWS, Azure, and GCP guys. And at that time, they came into the market actually. Initially, they came into market with the Azure people. Azure people with Azure cloud. Okay, that is the reason why Azure Databricks. See, Azure Databricks is Databricks is not a product of Azure, I can say. But people keep saying that Azure Databricks, Azure Databricks. Why? Because Databricks is a separate entity or separate company. And since these guys are actually tied up with the Azure and they are using backend Azure resources to run the programs or to manage, to process the data. Okay. And that too, Azure is actually releasing that as a service. See, in Azure, we have hundreds of services, right? So Databricks is also one of these service. They're launching it as a service. Nowhere they're mentioning it as a Databricks is separate, we are separate. No, they're not mentioning that one. They're just launching that as a service. That's it. Okay, that is the reason why that combination has become very popular in the market. That is the reason why people started saying that Azure Databricks, Azure Databricks. But Databricks is not a product of Azure. Azure is a separate company. Databricks is a separate company. Okay. And after that, actually, these guys started like focusing more on the AI part, and they started like raising the funds in 2019 and 20, and became big gained in the market. Now these guys are actually competitors to the Snowflake. What are all the features are there in the Snowflake? All the features are there in the Databricks as well. Everything, everything you name one feature in the Snowflake that is available in the Databricks. That is the reason why I never feel any difference in real time while working with the Databricks or Snowflake. I never felt like any difference. I feel both are same only. Whether you work with Databricks or you work with Snowflake, ultimately you work with the SQL only. Same concept. Backend also same thing only. But here in Databricks, more coding part is there. But in Snowflake, more SQL part is there. Of course, that is only the difference. Of course, if you want to manage everything in SQL in Databricks, you can manage that. But we don't do that actually. Getting my point? Clear, guys? Up to this?
Yes, sir.
Now you got good understanding what is Databricks and why they came into the market and who are they? Okay. Next, moving on to the architecture part. So this is the architecture of the Databricks. This is the generic architecture I can see, irrespective of the cloud. Okay. The cloud can be AWS, can be Azure, can be GCP. You see this Databricks is available in all the clouds, guys. But Azure combination has become popular. Even AWS also nowadays people started using. These guys actually started marketing like anyway. AWS people. And even GCP also started marketing that. Okay. So in the Databricks architecture, mainly we have two things, guys, actually. One is control plane, and second one is actually data plane is also there. I think control plane and data plane. Okay, I'll talk about that one in the Azure architecture. Now, first I'll try to talk about the Databricks this one architecture part. So I told you already what Databricks people are saying, telling to the cloud is, hey, we manage that UI, web application, everything we manage from front end and everything we manage. We will just try to utilize only your compute power and your storage. That's it. Storage and compute power. That's it. Rest all we will take care. That means whole control is with the Databricks only. So what these guys are actually managing from their end is Databricks end is web application. That means interface. Okay, let me open and show you how the Databricks interface looks like. This is the Databricks interface. I'll tell you how to create the account with the Databricks. Okay, so this is the UI because Spark doesn't have any UI, and that too, um, uh, yeah, they have to have some UI in place to execute your commands somewhere. So for that, they are saying that, hey, we have this UI. We'll try to manage everything from our end and compute orchestration. Orchestration is nothing but scheduling part. The scheduling part also we will manage from our end. Okay. Unity catalog. This is a new feature of the Databricks. Actually, I'll talk about that one maybe in the further classes. This is major, important concept, I can say. Because of this one only, the market Databricks actually captured most of the market because of this feature only. I'm going to discuss that one from tomorrow anyway. Okay. And queries and code, everything we will manage from our end. Okay. So what we do from you is what we take from you is we'll just take the compute power from you. In the cloud account, they will just take actually compute power. That's it. Okay, so this is what they're just taking from the AWS, Azure, and GCP guys. Okay, so we have serverless compute power also, guys, in Databricks. Okay, so even in the real time also we use the serverless only. If at all, if you want to have serverless compute power, that is completely managed by Databricks only. That is completely managed by Databricks only. If you other than serverless, if you want regular compute power, then they will take it from the cloud account. Okay, so now we understood this one, and this one as well. We'll talk about the differences between the serverless and this one. The mainly we don't need to wait until it get spinned up. The waiting time is reduced here. Okay, we'll talk about that one in a dedicated session. Okay, and the last one is actually Lakehouse Federation. This is also a new feature in Databricks. Let's say if you have any on-premise databases or cloud databases, right? You can expose that data to the Databricks easily, easily. Okay, so that is what we call it as a Lakehouse Federation. This one also I'll try to show you. Um, once we actually create an account and start using that Databricks, right? I'll show you that one. So on top of that one, I told you already, we have a security mechanism as well. We can create actually users, groups and everything we can create in the Databricks account itself. Okay, so this is actually a Databricks architecture, deployment architecture, I can say. As I was mentioning, this part is completely managed by Databricks company, and this part is managed by your cloud. Cloud can be anything. It can be AWS, Azure, or GCP. And this is the federated lakehouse. That means if you have any local databases in your cloud, then you can access those databases or applications from the Databricks account. Clear?
Yes, sir.
Now let's try to understand the same architecture with respect to Azure. Okay. Same way here also, we have two things actually. One is control plane and the second one is the data plane. Control plane, as I was mentioning, they'll try to manage the interface. Okay, so Databricks people are actually managing the Databricks UI to execute in order to execute your commands. Okay, and the notebooks also they will try to manage whatever the notebooks we have written right in on-premise. Similarly, we also create actually notebooks here that we'll try to manage. We'll start like understanding them from today. Okay. And we have jobs concept as well. We can create actually jobs in Databricks. That is also completely managed by Databricks. And we have cluster manager. Cluster manager is nothing but they'll just try to take only the compute power from the cloud people. And how it has to be managed backend, how they have to be managed. That is taken care by Databricks people only. So that is nothing but a cluster manager. Okay. And one more important one is that is DBFS. The full form of DBFS is Databricks file system. Okay. I'll talk about that one as well. Okay. So as I was mentioning you, cluster manager means, see, everything we manage from my end. I mean, when I say my end, Databricks end, I can say. And we need to depend on compute power on the clouds, right? So for that, what do they do is they'll just create a VNet, that is virtual network. Okay. And they just take the power from that network and they'll just try to create the clusters on top of it. Okay. So this is what the compute power, like I was talking, in order to execute your commands. See, some companies or some clients may need 10 node cluster. Some clients may need 32 node cluster as well. See, some companies may need high configuration, I can say. Few companies need only minimum configuration. I mean, depending on the volume of data that they're trying to process, guys, that's it. So all that compute power will be taken from here only. Okay. And one more thing is, let me show you one more architecture part, I can say. This is what I was trying to talk. You know what happens? Don't try to understand this terminology. Anyway, I'm going to explain that one from tomorrow. So we have actually a delta format, which is a one of the file format, I can say. I'm going to demonstrate that one as well after some time. Okay. So we have data. We have. Let's say my one of my client is actually sending the data or sending the files into data lake. When I say data lake here, this is my Azure environment. I'm talking everything with respect to Azure here. Okay. So they're sending the files into Azure Blob or ADLS Gen 2 location. So how we are calling S3 in AWS, right? In the same way, the storage we call it as a ADLS Gen 2. ADLS Gen 2. Gen 2 is nothing but generation 2. ADLS full form is Azure Data Lake Service. Okay, Azure Data Lake Service. So ADLS Gen 2 full form. Okay. So once the files are landed into Delta Lake, my Databricks has to go and talk to this one, right? This ADLS Gen 2, right? From there, it has to pick up and it has to process that data into next layer. See, in traditional warehouses, in the traditional ETLs, actually, we maintain three layers generally. Okay. Generally, people maintain inbound, okay, stage, outbound layers. I mean, the terminology may vary project to project. I'm telling you, like one of my previous project, they were using the terminology as inbound. This branch they call it as a inbound. Okay, this one they call it as a staging layer. So next one they call it as a outbound. We used to use the terminology. Now we have a standard terminology in Lakehouse that we call it as a bronze, silver, and the gold. Anyway, I'm going to talk about this one bit later. Don't worry. I'm just giving at high level what I'm trying to do here. Okay. So we once we take the data from this storage account, we need to take the data and we need to process that into bronze. We need to create tables actually in the bronze layer. And from there, we have to do some transformations and joins and filter conditions. We need to curate the data and load it into silver layer. And if at all, if you want to have any aggregations and all, then we can move the data to the gold layer. Okay, so from now onwards, we are going to talk everything with respect to bronze, silver, and the gold layers only. Okay, so raw data, we'll try to load it into bronze layer. From there, we'll just try to do transformations and all, load it into silver. If at all, if you have any aggregations and all, like we'll try to load the data into the gold layer. Okay. Okay. So, see, why I'm telling this point is ultimately we try to store bronze layer data in the backend database, of course. The backend database, when I say database, actually, backend, it stores the data in a ADLS Gen 2 only. That means your Databricks should be able to access the storage. Okay, that is what I was trying to talk here. So, irrespective of the cloud, your Databricks should be able to talk to the storage that you have in the cloud. Let's say if you take Azure as a cloud provider, so backend they'll try to choose actually Azure Blob Storage. They'll try to use that Azure Blob Storage or ADLS Gen 2, I can say. Okay. Shiva, we have already here Azure Blob Storage. Directly Databricks can come and access this one, right? So why do we have this one Databricks file system? We already have here ADLS Gen 2 or Blob or S3 or like Google file system and all, right? So why do we have this DBFS in place here? So one thing you need to understand here, if you're connecting this Databricks to the Azure backend storage mechanism is different when you compare with the AWS. In in AWS, we storage account we call it as an S3. In S3, we call it, we can create actually buckets. Inside buckets, actually, we can create folders. Inside the folders, actually, we can create subfolders and so on. Files, whatever you want, you can manage. But in Azure, we have actually storage account. Inside that storage account, we have actually what is that containers. Inside the containers, we can create the folders. Inside the folders, we can directly store the files or subfolders. I mean, the mechanism is different from cloud to cloud. Irrespective of that cloud, see, for AWS, if at all, if Databricks wanted to read the data from this Azure, it has to read in one way. If it is S3, it has to read in another way. If it is GCP bucket, it has to read in another way. Because the concept is different, right? Cloud to cloud. So instead of following different mechanisms, actually, what they are doing is they have one wrapper mechanism. They have one common file system on top of all these clouds. That is nothing but your DBFS. Okay, so once you're uh, storing some data in Databricks also Databricks can store the data, guys, but ultimately backend it is storing in this storage only. Databricks doesn't have any dedicated storage. So they have this DBFS in place actually. DBFS is just a wrapper on top of these storages. We will Databricks point of view, we'll go and talk to the DBFS only. Everything we talk with respect to DBFS. But DBFS backend is actually the cloud storage. See, what I'm trying to say ultimately is except storage and the compute power, rest all managed by the Databricks people only. Okay. When you create an Azure account, actually, you know what will happen? Indirectly, you're going to create an account with the Databricks also. I mean, if at all, if you want to create a Databricks as a service, I mean, if you create normal Azure account, that doesn't mean that you're creating the account with the Databricks as well. No, it's not like that. If you're spinning up the Azure Databricks service, then indirectly you're going to create an account with the Databricks as well. Okay. Now, Shiva, you may ask a question here. Shiva, we will start writing our commands in Databricks. We'll start executing our commands. Okay, that is fine. Now, once we get the bill in the month end, do we need to pay that bill to the Databricks people or do we need to pay the bill to the Azure people? Okay, so I'll tell you that one. See, back end Databricks and Azure people tied up, right? So Azure is providing Databricks as a service, right? We call it as a ADB, ADB, Azure Databricks. It is providing as a service, right? That means Azure is actually going to generate the bill for us. And they are going to pay back to the Databricks people in the backend. We don't need to worry about that one. Now Azure people is going to generate that because we are going to create a service in the Azure, not in the Databricks. Databricks just like trying to manage all these things in their end only. Okay, so your Azure account is actually creating a SSO, that means single sign-on, and they are going to manage everything from there. You'll understand all these things once I start creating an account. You'll understand, guys. I'll try to link again this architecture once you start creating the account and all. Okay, so for now, my point is here. Databricks is a third-party company. They tied up with the cloud guys, and from the cloud, they are just trying to utilize only the compute power and the storage. That's what I wanted to tell you here. Clear with this? Is it okay? or not?
Yes, Shiva.
Okay. Okay, now let me show you how to create an account. Let me bring up my screen. So this is what we used to use, right? We used to execute the commands, right? Okay. Now, if at all, if you want to create an account with the Databricks, right? What we need to do is we need to just type here Databricks free trial, because this is actually introduced very recently. Previously, we used to have till your last batch. Okay, this was introduced recently. Till your last batch, we used to have community edition, Databricks community edition. Now that is not there. I'm not sure still we can create that community edition. I don't think so we can do that again. Okay. So we can, how we are creating the free account in Snowflake, in the same way we can also create a free account with the Databricks. So what are all the things that you can do in the Azure Databricks? All those things almost you can do in the free trial account. Almost, not 100%, but most of the activities we can perform in the Databricks free trial account. Okay. I'm just trying to click on that link. I just typed Databricks free trial. Login.databricks.com free trial sign up. This is the URL actually to create a free account. I'm just clicking on this link. Ah. See here, similar to your Snowflake, these guys are also actually giving $400 dollars worth of credits. This is not a lifetime one, I can say. I mean, this is not a lifetime edition free account. Once your 400 worth of credits are over, they'll start asking the credit card, or if at all, if you want to continue, they'll start asking you the credit card information, or they'll suspend the account, I can say. Okay. So you don't need to have any cloud account here. You just need to have your Google Gmail. I can say you just use that Gmail here and start creating an account. Okay. The steps are very clear here. I'm just clicking on creating this one. I don't know. I'll just try to use this one. That's okay. Okay. Password it is asking. I forgot the password. Anyway, once you start giving that password and all right, it will create a free account within a single step. Okay. Just create that account. That account UI looks like this. Okay. Hmm. Well, I'll close this one also. Hmm. The account UI looks like this. The free trial account looks like this. I told you, right? That the features and the concepts and everything looks like Snowflake only. You'll see the similarities actually. I'll try to compare everything, every single feature with the Snowflake, so that it will be easy for you guys to remember. Okay. Shiva, like we don't understand what is this UI. Can you just explain to us? Yes, absolutely. Okay, what we do here is, let me click on this one. Let me click on these three lines, actually three bars. You see a lot of whole bunch of options here, left side. Workspace, recents, catalog, pipelines, compute, blah, blah, blah. Out of all these things, mostly we are going to use from here to here. Okay. I'll try to touch upon almost all the options that we have here. Of course, if I have time, I'll try to discuss the Genie and the dashboards as well. That means like how we are building the dashboards in Power BI. Similarly, we can build the dashboards in Databricks as well. They recently launched this feature actually. Okay. If at all, if you're working with any data science related activities, right? Then you can go ahead and use all these things. Okay. So currently we are discussing or we are focusing more on the data engineering part. So we are focusing all these options. Okay. I'll try to discuss one by one here. Okay. And the first one that I wanted to show you is workspace. Workspace is nothing but this is the place where you start like working on your regular activities, day in, day out activities, I can say. Okay. Once you click on that one, you can see here home, workspace. If you expand this workspace, actually, it's a kind of folder structure, guys. That's it, where we store our all our notebooks, I can say. Okay. So here we have repos. Since I did not configure any CI/CD mechanism, so I don't have any other folder here. We will do that one as well. We'll try to integrate this one with the CI/CD GitHub. Okay. So currently I don't have anything. This is a fresh account, I can say. I created it recently. What I do is what we do here is generally currently I'm with my I'll just expand my user. This is my username actually. Even in the real time also we create let's say if your company is XYZ, your username followed by that xyz.com like that you'll get. Okay. Mostly we'll try to create the notebooks and all under workspace only. But for now, I'm just going and creating under my user. That is okay. I mean, I'll do that one from tomorrow. For now, for today, only for today, I'll just go and create my notebooks and all under my user. Okay. So what I do is here, I'm just clicking on here. This is nothing but a folder here. In this folder, if at all, if you want to create any notebook and all, you can start creating that one here. Click on this create. You're getting a whole bunch of options again here. Folder, if you want to create, let's say, um, demo, Databricks demo or something, whatever you want, you can create that. I'm creating the folder called under my user. Actually, I created a folder called demo. So under that, actually, I can go ahead and create a notebook or file, Python file if at all, Python file or regular file if you want to create, you can create that. If you want to create a new query also I'll try to show you how to do that one. Dashboard I was telling you, right? How we build the reports in the Power BI. Same way we can also build here. Okay, we'll talk about that one as well. Genie Space is also similar kind of thing only. Similar kind of in the sense like you can start like writing your analysis in the normal plain English language. It will start like giving you the it will start building the reports or some analysis on the tables. Okay, that we call it as a Genie space. That also we'll try to discuss. If at all, if you want to build any ETL pipelines, you can build it. I'm not sure like what is this legacy alert and all, but this one is nothing but your machine learning experiment. If at all, if you want to do, you can do that one. Alert is nothing but this alert mechanism, sending an email when something got failed like that. Okay. So for now, I'll just create a notebook here. Uh, this is the notebook that this is the first notebook that I'm trying to create here. See, the UI exactly looks like your Jupyter notebook or not? But in the Jupyter notebook, of course, left side, we don't have all these things, but here we do have like database kind of look and feel here. Okay. So if you want to, let's say, rename this one, right? You just need to click on that one, and you can start like renaming the notebook names and all. So I just renamed my notebook name as demo, and you can start writing something here. So Python comments, whatever you know, you can. I mean, PySpark Python comments, whatever you know, you can start writing them here. Okay. So I'm just writing here, hello world. Okay. I'll just try to print it here and see what is happening here. See. See here, if at all, if you want to execute something, right, we need compute power. Okay, so that compute power is nothing but this one. So currently in the free trial account, we got actually serverless compute power. Um, Serverless compute power. I'll talk about this, what is serverless and what is job compute and all. I'll discuss about that one little later. For now, you just try to understand this is the compute power given by the Databricks people. Okay. I mean, you don't need to spin up that. Uh, Directly, it is available. Spinned up actually. We just need to start using them. That's it. Okay. So this is the compute power we need to use. And if at all, if you want to run something, you can use this run button here directly. Or if at all, if you want to run all the commands in all the cells, you can use this run all button as well. Okay. So this is one part. This is actually how we create like notebooks. This is nothing but a notebook, guys. Actually, I created a notebook only here. Okay, so this is how we create actually notebooks and start writing our PySpark commands here. And I told you already, we create that Spark session in the local environment, right? We don't need to create that Spark session in the Databricks. By default, that is enabled. Spark session is by default enabled in the Databricks. You don't need to write that 3 to 4 lines creates Spark session, and we used to write 3 to 4 lines of command, right? Now we don't need to write those things here. You can start reading the data here. I'll show you that one, how to read the data, how to. I have my just before this class I was practicing something here. This is that we know that this is the schema actually. I just mentioned in a list, and this is my data. One event A, this event date. Two event B. This is my data actually. I took it in a tuple format. When you say it is in tuple format, Databricks point of view or Spark point of view, these are the records. So you know spark.create data frame command, why we use. In order to create a data frame, we have to use this method actually. And we pass data and schema as an input to this one so that it creates a data frame. And we know like show command we use actually to display the data. Now let me try to execute that one, see how we are able to create that. See, it is displaying the data here. It is showing the data here. So this DF is nothing but a data frame, right? So in order to execute these commands, did I create any Spark session and all here? No, I did not. This is a fresh notebook, I can say. Nowhere I created that Spark session, but I'm able to see the data exactly how you're able to see it in local environment. I'm able to see that one in the cloud.
Shiva, by default, serverless compute path తీసుకుంటుందండి config.
Yes, yes, yes. Okay. Um, this is one thing. Okay. And I was talking about the Unity catalog, right? Okay. So, Siva, this Databricks is used only for executing your Spark comments? No, no. Databricks is also acting as a data warehouse. Okay. So when you say data warehouse, we should have database, we should have some schema, and we should have some tables, right? Where are those? Yes, boss. We do have that one here. I'm just clicking on SQL editor here, and I just opened a new tab. Now this is your data warehouse environment. Backend where they are storing the data and all that I'm going to talk a bit later. For now, you just try to understand this is just a data warehouse kind of environment here. Okay, so I'm just clicking on the symbol here so that you will see here. Where is this one? Why this demo date is still there? I dropped it already. Okay. Just a second, guys. I'm just trying to drop the database that I've created sometime back. I'm going to create a fresh one now. Don't worry. See here, extra small server is there by default. Similar to your Snowflake only, guys. Nothing difference here. Demo div is not empty. Oh, I think we need to drop the schema first, and after that we need to do that. Okay, so drop schema. Your schema name is actually test schema. Let me drop it first. Underscore, right? Sorry. Okay. Let me drop it. Okay, I think we need to drop the volumes first. I'm going to talk about all those things. Don't worry. Delete directory, delete directory. One second. Let me drop this. We can drop it actually. I'll talk about one by one item. Don't worry. First, let me drop this. Or otherwise, I can create a new one as well. That is also fine. We can delete actually from here. This is only the option. Uh, they're asking us to type all these things. I could have deleted it before the class. One second. Now drop the schema. Now drop the database as well. What happened to this? It should be able to drop it actually. Okay, somehow it is not deleting that one. That's okay. I'll check that one a bit later. Okay. Should be able to drop it. Catalog DB is not empty. I don't know why it is not able to delete that. Okay. Let me try to create a new database here. Forget about the drop commands for now. Okay. Um, I wanted to create a new database. So when I was explaining about the Snowflake, right? What did I do? First step, I created a database, I created a schema, I created a table in that one, right? In the same way, I wanted to do that here. Okay. I don't create the table at this point of time. I'll do it later. For now, I'll just try to create actually a database and schema. So for that, your regular database commands only. Here, database, we call it as a catalog, guys. The terminology little bit changed. That's it. Okay. Schema, we call it as a database. Regular data warehouses, what we call high level object is actually a database. Under database, we'll be having schema under schema, tables and views and all those things will come, right? Here, database, we call it as a catalog. Okay. Schema and database both are same here. Don't get confusion, or otherwise you just remember in this way. Catalog is nothing but a database. Schema is nothing but a schema only. Just remember it that way. Okay. Create catalog. Create or replace also you can use if you want. Okay. Create or replace catalog. Your catalog name we need to use. Okay. Let's say test underscore DB. This is what I wanted to create actually. One second. Create catalog. If not exist. Okay. Now let me try to go and create this one. R replace is not working here. Yeah. So my test DB is actually created. Okay. I wanted to create. Okay. So when you create a database actually, or when you create a catalog here, by default, you're getting two schemas. Did you remember in Snowflake also, we get two schemas, right? What are those?
Public and information.
Information
Same
scheme.
way. Same way here also, information schema and default schema. That's it. I told you, like 90% of the similarities are there between Snowflake and here. Okay. So under public, we did not have anything in Snowflake, right? Here also, under default, nothing is there. Okay. Uh, Under information schema, we used to have columns, schemas, views, and all those things, right? Same as it is things here also. As it is. Okay. That is one thing. Okay. I don't want to play with this default one. I wanted to create my own schema actually. So for that, I'm just trying to create here, create database or create schema. You can use any terminology here. Okay. I'll just try to use schema terminology only here. Create schema, schema name. So my schema name, I'm trying to use it as a test underscore schema. I'll just try to use this one. Yes, I created that. I created that. If I expand the test DB, let me refresh this one. Where is this one? Oh, I think it did not create that. Already exists, right? It's not refreshing, guys. One second. The free trial account, right? It behaves in the same way sometimes. Let me, it is there. Let me expand it once. Where is this? Oh, it has created. See here, I made a mistake here, guys. Sorry. So by default, the database is selected actually demo DB. That is the reason why it is creating like that. Now I selected actually test DB. Under test DB, I wanted to create actually test schema. Okay. Now if I expand the test DB, see, I'm able to see the test schema here. So under that, nothing is there. We'll start creating the volumes, tables, and all from tomorrow. Okay. Um, that's all for now. I can explain that volumes concept also, but I'll explain that one tomorrow, not now. Okay. Hmm. That's it.
So we need to set up context here as well. Just
Here
like
also, similar to your Snowflake. So their context is nothing but database schema, right? Here also, if at all, if
warehouse
you want,
and all.
warehouse also, right? Here also, we can select the warehouse. Currently, it is serverless only, but in real time, you'll get job compute and the serverless both.
And the sizes.
Along with the sizes. Sizes we cannot control in, I mean, we cannot control means we will not be having multiple sizes in Databricks actually. Automatic scale up option is there here in the serverless. But in Snowflake, we actually will get options actually to select the multiple sizes. But in Databricks, we don't have that. Okay.
While creating schema, we can give the fully qualified path, right?
Yes. Or if you are selecting the if you are setting the context here, you don't need to give that.
Yeah.
Based on that, you have to decide. I mean, whether you're giving it here or not. But in real time, mostly 99% of the cases, I follow fully qualified path, fully qualified object, I can say. That means database name dot, schema name dot, table name. Mostly 90% of the cases. See, do you see any differences here between that UI and this UI? Of course, see, you see these options here, but you don't find these options in the Snowflake. But most of the similarities are there, right, between Snowflake and here.
Yes, sir.
Yeah. Any questions? Okay, let me stop recording.